All right, readjust the number so the exponents are the same. Add or subtract the coefficient. And then convert the result to scientific notation. So remember, when you move it to the left, you're going to add to the exponent. When you move the decimal to the right, you're going to subtract from the exponent. When I talk about the exponents being the same, we're looking at what the times 10 is. So let's look at first, if I were to add, make them both 8. That means I need to move 1 to the left. So 0.245 times 10 to the 8th plus 3.8 times 10 to the 8th. So first we need to figure out the coefficients. The coefficients are the numbers that are being multiplied by 10 to the 8th. So 0.245 plus 3.8 is 4.045 times 10 to the 8th. We do not need to convert this result to proper scientific notation because it already is. So the next one, we're going to ignore that 0.5. That point should actually be a multiplication in front of that 10. So let's say that I wanted to subtract, make them both 5. So that means the 6.0034, I'm going to need to make that 5. So I'm going to need to move that to the right 3 places. So it becomes 6003.4 times 10 to the 5th and 2.456 times 10 to the 5th, and we're adding those. So if I look at that, 2.456 plus 6003.4 is 6005.856 times 10 to the 5th. This is one where you will have to readjust. So we will need to move it to the left 3 places. So we have to add 3 to that exponent. So it's 6.005856 times 10 to the 8th power. So if you were to look at them, which one do I have less steps with? Usually it's going to be when you're adding, so you're getting to the larger number. So for number 3, it's sometimes hard to see that that larger number is actually the smaller negative sign. So we want to move the 5.6 to be 0.567. So 1.4 times 10 to the negative 5 minus 0.567 times 10 to the negative 5. Because negative 6 plus 1 is negative 5. So we do 1.4 minus 0.567, and we get 0.833 times 10 to the negative 5. This one we will have to readjust, so we're going to have to add 1, and it becomes subtract 1. So it becomes 8.33 times 10 to the negative 6. So this is one that it probably would have been better to subtract, but unless you are really, really comfortable with them, it doesn't really matter. You're going to need to convert if you need to. If not, then you don't. It's just one less step. So for number 4, let's make both of those to the 7th power. So that means that I will need to move the 4.801 4 places, so it becomes 0.004801 times 10 to the 7th minus 2.2 times 10 to the 7th. So I end up with 0.004801 minus 2.2, and I get negative 2.1995199 times 10 to the 7th, which is proper scientific notation. The last section is word problems. So you're going to have a few word problems that have some scientific notation within them, and it's figuring out what to do with them. So the outer wall of a large tourist attraction in Cambodia is about 1.1 times 10 to the 3rd meters long and 8.1 times 10 to the 2nd meters wide. Find the approximate area. Remember, if you're finding the area, you're multiplying. So it's going to be 1.1 times 10 to the 3rd times 8.1 times 10 to the second. So you're going to need to multiply 1.1 and 8.1. 1.1 times 8.1 is 8.91, and then you add exponents so it becomes 10 to the 5th power. Next problem, the planet Mercury has an approximate mass of 3.3 times 10 to the 23rd kilograms. Mars has a mass of about 6.4 times 10 to the 23rd kilograms. How many times as great as the mass of Mercury is the mass of Mars? Round the coefficient to the nearest tenth. So how many times as great is a division problem. So we take the larger one, 6.4 times 10 to the 23rd, and we're going to divide it by 3.3 times 10 to the 23rd. You may have noticed that these two are the same, so they're going to become to the 0 power, which is 1. So you're really just dividing 6.4 by 3.3, and you get a large number, but it tells you to round to the nearest tenth, so it's 1.9 kilograms. Oh, and number 1 was meters squared. Number 3, the ocean is 6.4 times 10 to the 7th square miles. The area of the Arctic Ocean, I'm going to assume this means Pacific. So the Pacific Ocean is 6.4 times 10 to the 7th square miles. The area of the Arctic Ocean is about 5.4 times 10 to the 4th power square miles. Find the approximate sum. So we're going to need to add. In order to add, they need to have the same exponents. So let's make them both 7. So we need to move the Arctic Ocean 3 places to the left. So I have 6.4 times 10 to the 7th plus 0.00054 times 10 to the 7th. So we need to take 6.4 and add 0.00054 to it. And we get 6.40054 times 10 to the 7th power, and it is square miles. About how much larger is the area of the Pacific Ocean than the area of the Arctic? This one you need to subtract. So we do the 6.4 times 10 to the 7th. Since we already converted them up above, we're just going to subtract now. We're going to use the same numbers we used up above, so 0.00054 times 10 to the 7th power. So 6.4 minus 0.00054 is 6.39946 times 10 to the 7th power square miles larger. A blue whale has a mass of about 190 million grams. The mass of a whale shark is approximately 2.6 times 10 to the 4th power kilograms. So if you notice, first of all, kilograms versus grams. There are 1,000 grams in a kilogram. So what we need to do first is we need to divide this number by 1,000 to figure out how many kilograms that is. So we do 190,000,000 divided by 1,000, and you get 190,000 kilograms. Now we need to figure out what is that in scientific notation. Well, in scientific notation, that becomes 1.9 times 10 to the 5th power kilograms. Now what is the approximate sum? Let's make them both to the 4th power, or to the 5th power, so we will need to move this over. So 0.26 times 10 to the 5th plus 1.9 times 10 to the 5th. 0.26 plus 1.9 is 2.16 times 10 to the 5th power kilograms. Given that the mass of white rhinoceros is about 4,850 kilograms, find the combined mass. Well, this is going to be 4.85 times 10 to the 3rd power. So if we make them all to the 5th, then this is going to go over 2 places. and now I have 2.16 times 10 to the fifth. That's the combined of the first two, and now I'm combining just 0.0485 times 10 to the fifth power. So 2.16 plus 0.0485 is 2.2085 times 10 to the fifth power kilograms combined. All right, we finished all the notes. Be prepared to practice those next class period. You now know how to add and subtract and do story problems of scientific notation.